How you going, everyone? This is the first devlog of my currently untitled stealth-based Quokka-inspired Metroidvania, which is a mouthful and mostly gibberish. Anyway, for anyone who doesn't know, Quokkas are these smiley marsupials in the macropod family, native to the southwest of Western Australia, which is where I'm from.
Cool.
But they're particularly known for being pestered by people for pictures on Rottnest Island off the west coast. Fun fact, the island's coloniser name comes from the Dutch phrase Te-eiland, I'm not going to pronounce that, but it means rat's nest island since the marsupials were mistaken for large rats by Dutch explorers in 1696.
Cool.
Also, quokkas sound like this. Anyway, in this video I'll be setting up the basic player controls and movement, and basic NPC movement and vision cones, and I go into way more detail than I originally planned, so let's get into it. I opened a new Unity project for my stealthy Metroidvania. So stealthy in fact, even the title's in hiding. Okay, but seriously, if you have any name ideas, definitely feel free to pitch them to me. I always overthink this shit and I'm not naming it Quokkavania. The gist is you're a quokka on Rottnest Island dodging all the selfie-hungry humans. You collect items, unlock stealthy abilities, and sneak into new places to grab even more stuff. A basic Metroidvania gameplay loop but with stealth. How exciting. I dropped in the player character with a super stylish square sprite and gave them their first script. I started setting up inputs like I did back in Wombatvania, using Unity's input system to check for horizontal and vertical inputs, which seemed like a solid plan until Unity hit me with an error because they'd changed the default input system since I last started a new project. The first code I added into the game and it all has to be deleted.
Wow, we're really off to a flying start, huh?
I know. The new system does seem like a definite upgrade though, so it's time to read up on the documentation and binge a few tutorial videos. I set up a new player input action map, or PM, added arrow key bindings and did a quick console log test, only to get another error. Turns out I was treating the input like a button when I just set it up as an axis. Before changing that, I added a use button input mapped to the spacebar to output to the console, and it worked.
That's great, man. You lose some, you win some.
What? That's not... Thanks. As one final check, I wrote a bit of code to print out the movement input as a 2D vector. The left number's the X or horizontal axis, and the right's the Y or vertical axis. And they were changing as I pressed the arrow keys, so I think I'm getting the hang of this new input system. Time to get some actual movement going. I started by making the player's rigid body move every frame based on the input direction and a move speed value. It's always good seeing the character move around for the first time, but the rigid body was living up to its name. Very rigid, very body. Kinda like the retro top-down games, but I wanted it a little smoother in my case. I added acceleration and deceleration to the movement script to add as a force to the character instead.
Acceleration and deceleration? Slow down, Einstein.
The player presses a direction and the code speeds up the character to a max and holds it there. They let go and the character slows down and stops. Simple. I toned down the acceleration to see if it was working, and it mostly was, until you tried turning at max speed. Since the character's at max speed, the code ignores this part and just turns them immediately. I fixed it by always applying the force in the input direction no matter the speed. And here's with a higher acceleration. It technically holds at max speed while turning, which isn't accurate, but I later tweaked it to Newtonian perfection. And at this stage it was at least starting to feel like I could be a little marsupial running around Rottnest Island. Fun fact, the traditional Noongar name for the island is Wajimuk, which means place across the water where the spirits are, and was named over 7,000 years ago when the sea levels rose enough to separate it from the mainland, which I think is more interesting and accurate than Rat's Nest Island. I made a Trello board to keep track of everything since it seemed to work last time, when I actually started using it. Once I listed everything I wanted in the first 3 versions, I could check off the first task and start on NPC movement. I added the NPC object to the scene, made them this shade of red, and gave them their first script, NPC movement. I set up some follow points which were just empty transforms that made up the patrolling path for the NPC. The code starts the NPC at one point and moves them towards the other. Alright, I'll just give it some movement speed and it should... Oh. Since the follow points were children of the NPC object, they move with it. which, to be fair, is a rookie mistake.
Mistake.
Yes, a rookie mistake. I was just saying that. I swapped position for local position, and there we go, movement. It was very basic and very rigid, but also very working enough. I wanted to have any number of points for the NPC to loop between. The NPC's script takes in the list of points, and on every frame, moves it towards the next one, and once it reaches it, moves it towards the next, and so on.
Wow, so high tech.
Yeah, well I later cleaned it up with a proper finite state machine so they actually do different things at different points, but this janky version did the job for now, so let's move on to player detection. To help the NPC detect the player, I gave it a script, Vision Cone, which uses Unity's overlap circle all to check a radius around them. If the player's within that range, it calculates if they're also within a certain angle and toggles the boolean can see player. I also made my first gizmo, which was pretty exciting. It draws lines in the editor for the radius and angle from values in the Vision Cone script using this kind of confusing trigonometry. At first I only pointed up, but I was just happy to see it working. I added a green line to the gizmo that points towards the player if it sees it. Except something was off because it was apparently seeing the character when they were outside the radius, and in the wrong direction.
What?
I know. Anyway, after some trigonometric soul searching, I fixed that up and made the logic for the Vision Cone actually face the direction of the NPC's movement, and the detection was all working, even if the gizmo was still not quite right. I'd also added a rigid body to the NPC and moved it using similar physics code to the players so they turned a little more smoothly at each point. After a bit more cleanup of the gizmo code and a whole heap more trig, everything was working as intended. I can change the radius and angle in the editor and watch the gizmo change in real time. I wanted the NPC's movement to be obstructed by things like walls because at this point it just ignores them. I added a raycast that checks for obstructions using a layer mask. If the ray hits a wall before it hits the player, they can't be seen. It only checks every 0.2 seconds, so there is a slight delay, but it won't be noticeable during gameplay. But since the quokka, or white square, doesn't have any stealth powers yet, you should help it out by sneaking up on that like button and taking it out. And probably just hit subscribe while you're there as well.
Not for you, right? For the quokka.
Yeah, for the quokka. Alright, back to NPC movement for a bit. At the moment they would just sprint at full speed until setting their new target, but I wanted them to be able to slow down as they approach certain points. I added a bit of code that calculates their distance to the next point and adjusts their speed based on that and a slowing distance that I can tweak in the editor. With it set to 5, they start slowing down 5 units out. And the same goes for any other value I set it at. Next, I wanted them to be able to pause at certain points, which I later solved with a finite state machine, but for now I wrote a simple coroutine which stops their movement for a few seconds at each point. Alright, let's run it and see what happens. They move to the next point, stop there, kind of. Why are they wait, where are you? What the fuck are you doing? The gizmo gave me some clues, but to be honest I still don't fully know what was happening here. After cleaning it up, things worked better, but the NPC would still creep forward slightly instead of actually stopping, and would still go to the wrong one. Eventually I got it right. They now pause properly with different wait times at each point. 1 second at the first, 2 at the second, and so on.
Wow, it's like a fully fleshed out person.
Again, the finite state machines will help with that. But then there was a new problem. Since the vision cone was tied to movement direction, when the NPC stopped, the cone opened up so the NPC could suddenly see in all directions like some kind of stealth game nightmare boss. I fixed that by only updating the cone's direction if the NPC was moving. Now when they stop, the vision cone stays pointed in their last direction of movement. I then added a basic detection UI by adding a Text Mesh Pro object to the NPC and made its value tick up by 1 for every frame that the NPC sees the player. You can see its suspicion score skyrocketing here. It's all good that I can see the vision cone in the editor, but the player can't actually see it in the game. Time to actually render it in-game. I first made it a child of the NPC, or a child object, so it can handle all its own logic and rendering code. I wanted full control over its transparency, radius and angle, so instead of a sprite renderer, I used a mesh renderer, which I'd somehow never actually used before. I followed this method: shoot out a bunch of rays in a cone shape according to a set count and angle, save the positions as vertices, and connect them as triangles to form the mesh. The outline showed up fine, but the mesh itself wasn't rendering, until I thought to check in 3D and realised the cone was just being shy and only showing on its back face. One quick reordering of 2 lines of code later, and there we go, a big slice of pizza. Now I just have to get it rotating with the NPC, since you can see here that the mesh rendering was disconnected from the actual detection logic. After updating the code to calculate the start angle of the vision cone according to the NPC's facing direction, it looked like this. It now rotates with the NPC, but it goes right through walls, which would be confusing for the player. So I updated the code to stop each ray where it hits a wall. That fixed it, even though it still turns quite rigidly. But I made it smooth later on, and it was working well enough for now, and I wanted to add a camera controller next.
You never actually finish anything before moving on.
Hey, I eventually come back to everything.
Whatever, do the fucking camera stuff.
Yeah, I'm actually ending the video here.
What? Then why'd you even mention the camera controller?
In the next video, I'll add the camera, update the detection UI a little bit, add some collectible items, basic win and lose states, a few bug fixes, and a finite state machine to control the NPC's actions and movement, and maybe some character art depending on how long the video gets. So stick around and follow along for more devlogs like this. See ya folks, have a good one.